Okay, so now what would happen if you wanted to solve where you have an equation where one absolute value is actually equal to the other absolute value? So in this case, what we still want though is we want to remove the absolute value and set it x equal to y, and then set x equal to negative y. So in essence, we're actually doing the exact same thing. It's just there's a little bit more going on. So this one is solved graphically. And remember, we were talking about to solve it graphically, we take the first side, we set it equal to y. Here's the graph, and that's why they put the equation right next to the graph. So that's the graph, y equals 2 times the absolute value of x. Okay, and we see that our absolute value just gets a little more accelerated, so it's a thinner v. And then we have the second side, y equals the absolute value of absolute value of x minus 6. And if we want to solve this, so that's solved graphically. We can actually see, what's cool about the graph is we can see what x values, what are the solutions there? Can anyone tell me? Negative 6, 12. Where did I get that information from? The ordered pair, right? And then what about this one? 2, 4. Yeah? Okay, so now how would we solve this algebraically? To solve it algebraically, we're going to take 2x equals the regular x minus 6. You leave that side the same. Or 2x equals the opposite of this. So negative x minus 6, right? So the first one, how would I solve for x here? What would I do to get x by itself? Subtract x from both sides, maybe? So I get all the x's onto one side. What do I get on this side? X equals negative 6. Good. For this one, if I want to make that whole side negative, what would I need to do with that negative sign out in front? Distribute. So I get 2x equals negative x plus 6. Do you see how I changed the signs of all of that? Okay, now what should I do to solve for x? Good. Add x on both sides, and what do I get? 3x equals positive 6. What should I do now to solve for x? And I get x equals 2. So see on my graph how I have x equals 2? Here's my x equals 2, and here is my x equals negative 6. So those are my two solutions. So I can put that in set notation. Negative 6 and 2 are my solutions. But how do I really know that they're correct? I would check. Okay, so the check would look like this. Take them one at a time. 2 times negative 6. Is that absolute value equal to negative 6 minus 6, the absolute value? So we have negative 12 equals negative 12, and 12 equals 12. So I checked one of my solutions, and I should go ahead and check the other one. Now, actually, you might notice that 12, right? Check it out. When you plug in x is negative 6, there's your x, you get y is equal to 12. So that ordered pair actually tells you the x that was the solution, and it tells you the y, which is actually what you get when you check it. Okay, now I'm going to check the other one algebraically. So I take my absolute value of 2 times 2. Is that equal to the absolute value of 2 minus 6? So I have the absolute value of 4 equals the absolute value of negative 4. Is that true? Yeah, 4 equals 4 is true. So both of these, I wasn't sure. I put the question mark above the equal sign since we're not sure if it will check out. And then since it did check out, that's what we get. So solving it graphically versus solving it algebraically. So you're pretty much doing the same thing that you did. Okay, so I'm going to ask you to try now example 6. You have several different examples in example 6 to go ahead and try. I would say for something like this one, D, what do you think you might want to do in order to get that one ready to solve? I think you should go the absolute value of 3x equals the absolute value of 5x minus 2. What did I do to get that absolute value of 5x minus 2 onto the other side? I added it. I added it to the other side. Okay, if you were to do the same thing here, you would subtract it. But you still are going to use that same idea. Now, you might also check these by practicing your Desmos graphing them, right? If you were going to graph the first one, solving it graphically would mean you would go y equals absolute value of x plus 4, and then a second equation, y equals absolute value of 3x. Oops, I'm not showing that. Sorry about that. So in order to solve it graphically as another way to check it and get practice with Desmos, you would set each side equal to y and graph two separate absolute value in order to see where they cross. So go ahead and try those problems now, and then we can go over them in groups.